Well, hi, good morning. Thank you so much for joining me in my shop here. It's August 28th today. It's gray and cool outside. And the promised heavy rain that was supposed to come yesterday never showed. You got nothing, no rain at all. Spent the whole day waiting for it to rain and it didn't. The radar kept saying, yeah, there's rain coming, but somehow it's like there's an invisible shield over top of the city I live in. And storms seem to split and disappear and fade out, and somehow I'm complaining about not being rained on. How's that for strange? Now, what to do with this radio? So I got an interesting idea. A chance to employ this guy here. This is a Heathkit TV alignment generator, but it does something that my other sweep generator can't do. This is my other sweep generator hidden behind all these wires here. That only goes up to 5 megahertz. This guy goes way up to 150 megahertz or something like that. And it's called a Wobbler. The sweep action is controlled simply by the 60 cycle line voltage coming into my house. So it's sweeping back and forth at 60 cycles a second, and the sweep span can be huge, many megahertz of sweep. So I've almost never used this. I fixed it up, played with it a little bit, but now I'm going to try to put it to work seriously today. I'm going to try to sweep this radio and examine its response curves as best I can. And how's that going to work out? Well, you and I are both going to find out if it works out at all. It's very challenging stuff. I'm going to start off with a cup of coffee. Okay, because probably you've never seen one of these guys or anything quite like it. This thing here, I'm going to talk a little bit about this. It's really meant for television alignment, but because it reaches up into fairly high frequencies and I don't have anything else that'll do that, it's handy for trying to sweep shortwave radios. So it has two oscillators in it. It has a main oscillator and a marker generator. I won't be doing anything with this marker generator. Instead, I'll be using this oscillator. It has bands and scales, but the frequencies are way off. So in order to know what the frequency is coming out of this, I'm going to look at it on my SDR radio. My SDR radio is sitting right here. You can just see it here. And this is the RF output, and one of these leads, this one down here, is going straight to the SDR. So I have another output lead coming here, and it's coming around, and it's going into the antenna jack of the radio. So whatever this thing's producing is being stuck on the antenna jack of the radio and the antenna jack of the SDR. So we'll be able to see on the screen, I'll put it up on the screen here, where exactly the oscillator is oscillating, and most importantly the wobble in it, or the sweep in it, what the range of the sweep is, where it's starting, where it's stopping. So we can tune the radio to within that range and have the sweep passing across the tuned frequency, the very small bandwidth on the radio here. We can then observe the output from the radio, different stages, different points along the radio as the signal's progressing through it. This is what I hope, anyway. Will I really be able to do that? Well, we're going to see. My thinking here is we'll put it on the oscilloscope, and I'll use a scope probe, and we'll go through the different grid caps here. This is not the best way to do it, but you know, alternative ways are more difficult, much more difficult. This is really easy and quick. We can check, see what we get on the oscilloscope, if we can interpret it in some way and gain some more knowledge about the radio. To a large degree, what this is me messing around with the radio, and in that way learning more about it just by messing around. So even if this doesn't work out in the end, if we don't learn anything from the equipment about the radio, we're bound to learn a bunch of stuff in any case, just by doing this. Also, it has no impact on the radio. I'm not cutting any wires. I'm not taking parts out. I'm not doing anything. I'm not even pulling the tube. I haven't even pulled the tubes out of this radio yet. They're still sitting in their original seating, if you like, sitting in the original seating. At the moment, I have the scope connected to the other side of the antenna input. You can just barely see it. No, you can't quite see it. But down here is where the antenna comes in from the side. There. Here. Whoops. And I've got my oscilloscope connected to it. So I'm not so hopeful about what we're going to see on the oscilloscope. Now, if you're familiar with sweep generators, you know that the idea is you sweep across, let's say this is the screen, you sweep across the screen. The other channel of your scope or whatever is giving you the vertical display. So you're hoping to get something like this come up on the screen, something like that. And then it sweeps again, and sweeps again, and makes a nice picture. On the way back, the beam is either blanked or just moving so fast that it doesn't put a line on the screen, you can't see it. Either it's blanked out like in a television set, or my oscilloscope here may very well blank on the way back. This guy, no. This guy's sweep is set by the 60 cycles coming in. The 60 cycles, as you know, it's a 60 cycle thing. It's a circular thing. So it's going back and forth. It's fast in the middle, slow at the ends. You can picture a circle and something going around the circle, and then you just tip the circle like this, and you'll see something doing this. And that's exactly what the sweep does on this. Back and forth. It's not a one-time through thing. It's back and forth. And sometimes the sweep lines will separate because of a little bit of capacitance or something in the way things are hooked up. And instead of getting a line, you get a bit of a circle, and then the vertical part is impressed on the circle, and it looks a little messy at that point. So that's why interpreting it on the oscilloscope may not go so well. Besides, I have a wire hanging right in front of it. Another possibility here is to observe the signal as it passes through the radio right on the SDR. Once I've used the SDR to set up the sweep, we can then take the SDR input and literally connect it to one of these probes and just poke along here again and see what's to be seen on the SDR. I'm a little more hopeful that we'll see something interesting on the SDR. Now, making the SDR work for this is tricky. The SDR has its own automatic level controls and stuff going on, and it often produces a really shaky image and jumping all over the place, when in fact there's something fairly smooth in there to be seen. And what I found is if you reduce the I'm forgetting the name now, the if you make the image persist longer, then it will repeatedly paint over with its shakiness. But if you do it right, boy, this is a terrible explanation. I'll show you. On the SDR, you can finally get a fairly decent looking display, similar to what you would be hoping to get on the scope. So that's what we're going to do today. That's the plan, and we're going to see what we can see. Now, of course, I have this radio operating, and yeah. So before starting all this, I think I actually do have to start this up here, because I've got to warm this guy up a little bit. So let's flip him on, and I'll see if I can get the SDR onto the screen here. There's no sound, no sound to hear. So here we go. It's just taking a little bit of time. Okay, I'm going to flip to the SDR now. Okay, let's play it. Now, I was in here last night getting this going, trying to find out if this sweep generator still worked, because I haven't turned it on for so long. But it does work. So on the SDR here, this is the sweep area here, from here to here. Okay, it's higher on the ends simply because the signal is spending more time in this area. And so the SDR's result is it shows it a little higher. So there's some distortions that the SDR will introduce. You can actually see on the waterfall display the individual sweep going back and forth. can down here you can see the individual sweeps. 60 cycles a second is not that fast in the world of scopes and electronics and the like. Now I have an adjustment here. I can expand the sweep width. See, and I can expand it way out, which is the great feature of this sweep generator. I can expand it way out until it's many megahertz wide. And I guess that's for television. Old television channels were 6 megahertz wide, so maybe you had to sweep, 8 megahertz or 7 or 8 megahertz across it to see the whole thing. So you can see the adjustment over here. This is what I was trying to remember. S decay. See, if you move this up, and you start getting one of these shaky things, and it's hard to interpret. You put these things down, stuff smooths out a little bit. Spectrum speed. I'm not sure that's really helpful. Faster might be better here. So what I can do now is I can tune the radio within this band, or I can set this sweet band to where the radio is tuned, one way or the other. And this, if we were to listen to this, we would hear a 60 cycle buzzy hum come out of the radio, because every time the sweep passes the tuning point of the radio, there's a response in the speaker, which we can hear if we care to. So now the radio fairly quickly converts the incoming signal, like this 12 megahertz signal, converts it down to 455. So we'll only go a short distance before the picture kind of changes in the radio. And again, this is all about, not all about, but partially about just getting familiar with things. So we're going to set this up right on 12 megahertz. Let's do that. Why? I don't know. It sounds like a good idea. So here's 12 megahertz. I can just expand the sweep to cover it. That's really not a problem, or I can just kind of move it because ooh, okay, so I just bumped the antenna lead. I like that. Something's a little loose here. Ooh, that's not very good. I like the weaker signal going to the SDR. Okay, right, so we wanted to change the frequency of this downwards, like about like that, and then make it smaller. So we're just sweeping now pretty close to the 12. Now you can see this funny little dip here. Who knows what that is? Just an artifact of the SDR probably. So we tune a radio to 12 megahertz. We should hear this thing. Well, that's an interesting thing. Can we hear it? Is it just blasting away in here? Did somebody notice my meter go down here? What happened? Oh, that's not good. Okay, so we're going to tune in 12 on this. 12 megahertz. That's the sound of it right there. How do I know? That's how I know. So there we are. Very good. Forgetting how to turn off the radio. Okay, next step will be to start sweeping. Yeah, start sweeping through the radio, and we'll have some fun. See what happens. Okay, this is liable to get a little difficult from a videoing point of view, but let's start with. We'll fire this guy up. I already have him 12 or tuned to around 12 megahertz or so. And let's start this guy up here. So I'm trying to remember how to do it properly. So first thing is to turn on the heaters. I'm just checking the heater connection here. Good. Is it good? I don't know. Check it here. Okay, we're good. So heater's on. Okay. The lights have come on down here on the panel. And we're going to give it a moment. Headphones, that's what I'm missing. I got to wear headphones to hear this. Okay, let me turn the volume up on my sound panel here. So all that's happening here is just heating these tubes up, and that's what you hear right now. Okay, let me turn it down. Now we're going to bring on the B plus here. There we go. Let me put on my B plus meter. Okay, I'm going to raise the B plus. Should come on right about now. Should hear it. We don't hear it. How come we don't hear it? I'm not hearing it. I'm hearing nothing. What's gone wrong? What's gone wrong? We definitely have 300. We have 175 volts or so on here. Say 150. How come we're not hearing it? Well, it's possibly because I have it plugged into the sweep, and we don't have it tuned properly to 12. The sweep was running at 12, right? Let's just get this heard. So we get 12 megahertz here. We got to be up around 360. That's exactly where I am. 360. Okay. Anybody, somebody. Oh, that's interesting. What changed there? So I just turned on the BFO briefly and turned it off, and that either mechanical shock or the electrical shock has solved a contact problem or something of that sort. I don't know exactly. So now we're listening to it. Let me turn it down here. Again, I apologize in advance for losing control of the volumes. So we should be hearing the sort of sound, or a buzz. Actually, a buzz is what we should be hearing. So this is probably not tuned. Here it comes. Okay, we just went right through the sweep range, if you like. Okay, we don't need to listen to it. What we need to do is look at it. So, turn on my scope here. See, the scope lead is already connected to the antenna. So I came in last night and I tested this box to see if it would work. Okay, so you see a line on the scope here. That's not from the scope's sweep. That's coming from this box again. There's a sweep output right here, which is connected to the X input, and I have this set on XY. That's what's going on. The sweep coming out of here is nothing more than the output of a transformer on the line. So it's a 60 cycle AC signal coming out of here, nothing more than that. And that's just causing the sweep to do this back and forth thing, as we talked about. Now, I'm seeing nothing, no vertical change at all here. So there is attenuators on the output of the box here. And they are set, wow, it's set pretty high. We're not seeing anything. This is ×1. What? Oh, that would be why. Okay, I've got a different probe plugged in right now. That would be expensive. Oop, goodbye to that probe. Let's put this one in. Hey, there we go. Now we're seeing something. So let me turn down the sensitivity here. Okay, so from a distance it looks a little like a dog bone, but really you should think of this as the dog food can tipped a little bit. So you're looking at the can, it tipped just a wee bit. That's what this looks like. It's out and back, and there's some capacitance that's causing the out and back to not be right on top of each other. We'd see just a I was going to say a square rectangle, but I guess you can't have a square rectangle. You just see a rectangle, but instead it's as if it's been tipped, probably due to some capacitance. So that's interesting. So I switched this to ×10, and that seemed to remove the capacitance now. I'm going to change the output strength here, and we'll see this go up and down. It's not going up and down at all. Okay, what's happening? Jim, why did that happen? What is this? This is not coming from here. What are we looking at here? Uh-oh. A mystery has developed. Okay, so I'm going to stop. I'm going to get the screen a little bit better for doing this kind of stuff, and we'll continue exploring what is going on here, even if I don't know what I'm doing. Okay, we got the shooting match on the screen now. So why did the output not go up and down? Let me try this. Well, it's not changing much at all. So it really went right down to nothing on the SDR, but how come on the scope it remains the same? Oh, I got no answer to that question. Yeah, so what I'm doing here is I'm adjusting these. This is the attenuating control. It's certainly effective on the SDR. Maybe it's because I don't have this grounded. Yes, let's try that. Hey, that's a little better. Okay, so we need to ground this. I didn't ground my scope lead here. What could we ground it to? Probably not the best thing. Yeah, let me just clip it on here. Okay, so wait, you couldn't see what I was doing. I was clipping this ground lead from the scope lead, which I didn't have connected. Okay, that's a little better. Let's try this level thing now. Okay, we can see. Oh, beautiful. And I bumped this ever so slightly. Look at that. It's a wonky thing I've got set up here. It's wonky. We need it. Okay, so the SDR's got something funny going on. It's showing something here. I don't know what that is. I'm going to change the sweep width. Oh. I don't know what it's doing, but it'll matter. All that will matter. Like it's all we're going to hear in the radio or examine is just a little piece of the sweep here. Hopefully, it won't matter much. I don't think. What's going on here? I feel like I should run for coffee. Look, this thing starts here and goes way out. Let me turn the sweep width right down to nothingness here. Oh my gosh! Look at all that stuff in there. That looks nicer. Leave it like that. Just leave it like that. And what have we been hearing here the whole time? So that's the radio. What I'm doing is I'm turning the volume up on my sound panel here. So you can hear it. Is it really the radio we're hearing? Absolutely. Okay, now the name of the game now is to take this situation and make observations that somehow help me know something about this radio. So I think first we'll try with the scope, and I'll take it off the antenna. We should explain what we're seeing there. What are we seeing there? Wow, it looks like part. Now, is that what we're supposed to see? Or is that what we're supposed to see? Based on the SDR, it looks like... oh, what a lousy connection I've got here. Okay, you want to see what I'm doing? I'm just fooling around with this monster T arrangement, which is not reliable. You know, maybe that's not correct. Let's carry on fooling around. Fool around some more. And watch your fingers now, Jim, because the set is on and there's some voltage in there. And it could Oh, whoa. Oh, that's a good move. That's a good move. That's a good move. Hey, what's the sound like? Nothing. Okay. What exactly are you doing? I don't know. I don't know what I'm doing. Gotta put a better ground on here. I might clip it in here. So, tubes are 1, 2, 3, 4, 5, 6, 7, 8, 9. I almost counted 10 there. There's only 9. What have we... Now, I'm going to touch this to the grid cap. This could throw the radio right off in the first place, just doing this, because the grid circuits are sensitive. They're high impedance. Small change, big effect. So you can see the big effect. Now, I got my scope on DC. I'm going to flip it over to AC. There we are. We see something. Only on the scope now. The SDR is still showing us what's being presented to the radio, and the scope is showing us what can be picked up. This is on the first tube. The whole thing is there. Second tube much less. Let's do a little tuning. Things happening there. Anybody want to try and interpret that stuff? So I think we're moving. We got the sweep going. Where's my hand? Here it is. I'm showing my hand to you and you can't see it. Got the sweep going and I'm tuning in and out of the sweep. Tune out. I'm out of the sweep. Tune in. So right in the middle here should be 12.5, basically 12.5 megahertz. So the numbers on the front of the radio, 260. You can go 260. You know, 10.5. We're nowhere near the 12. So there's certainly a local oscillator issue with this radio. I think we can be pretty sure of that. It's way off. Okay, I'll go to the next tube. You're basically getting the same thing, not much of anything there. I got this set on times 1. Let me put it on times 10. And it probably won't affect the radio, but it still affects the radio. Okay, back to times 1. We go to the next one. Skip the next one. Go to the next one. Okay, so now I think we must be into the IF by now. Well, these three are the IF. I really don't know what's going on with these tubes in the order that they're in. Let's just go and poke. Now that is interesting. That is interesting. Let's just I can increase the input signal. Can I get this clip to stay on there? I don't think there's any way. There's nothing for it to hook onto. Let's turn this down. Turn up the input signal. Change hands here. Can I pull that right off? Yeah, pull that right off. Change my ground connection to somewhere better. Oh, here's an actual ground connection. Let's go there. Okay. Now, I'm going to increase the signal input. It's not changing it much. The attenuator, this should really boost it. Oh, you know what? It's the opposite. I've got the attenuation now at 10,000. So I think it's shrunk the signal by a factor of 10,000. Doesn't look that way on the SDR, but the SDR could be compensating for the increase in the signal. Now, something else that's interesting. Only here can you see it. Is that just because of level? Yeah, probably is just because of level. The SDR can still show it. Meanwhile, this guy can't. What are we going to learn from this? what are we going to learn from this? So there's a bit of a response shape there, but it's kind of small, and I don't even know what it is. It's still just the RF signal. Has not been converted yet. No, that's not possible. This many tubes in? I better find out what each of these tubes do. Now I'm going to the IF. Well, why are we getting two things there? Okay, I was not expecting two things to show up there. We'll go to the next one. Oops. Definitely need longer. I need longer ground piece here. Let's go like this. Go here. Okay, we'll go in here. Look at quite a different, and it's getting bigger all the time. That's good. I tune the radio a little bit. Moves around. That's good. The next tube is the detector tube, and I'd be looking at the audio. Let's do it for fun. I'm not sure it's gonna. Oh my gosh, there's still stuff there. So going right back to the first tube again. First tube, I guess you could say the bandwidth of the radio is gigantic. It's letting the entire sweep through. If I change the sweep width bigger, oh, it doesn't. You might want to try to interpret that. You can see the sweep width getting bigger on the SDR, but it responds on the scope. Don't know how to interpret that. So right now we're sweeping from basically 12 to 13. So this is 12 megahertz and this is 13 up here. Kinda. Okay, we'll go to the next tube. How come much less? Now again, when I connect my scope, I could be throwing the circuit off. So when I go to the next tube here, and the signal appears weaker, it could be because of the scope itself. And I've got this on ×1. Let me put it on ×10. First tube. Well, number 1 tube. Number 2 tube. Number 3 tube I can't do. Number 4. Listen, I picked quite a DC voltage here on this one because it really jumped there. Not sure why it's doing that. I'm wiggling the prod a little bit. Wiggling the tube, man. Bad tube contact. Next tube. Again, DC voltage there. There's a capacitor in the scope. I have the scope set to AC, so there's a capacitor that's going to charge and discharge. Okay. So now we get into the IF, and the picture looks very different. We've gone from the where's the signal again? I'm skipping one tube here all the time. So the broad. Oh, wow! I'm driving it. Why would that shoot way up like that? Is that because I'm really not tuned? Oh my gosh, I think that's the case. Hey, now what do we got? Wow, okay, this is interesting. No idea what it is. Let me broaden it out further. So by increasing the sweep width, the sweep range rather, but leaving the width the same, you compact the view. And that's what's happening. Is I increase the sweep, I'm compacting the view. Holy smokes! Never mind the SDR. What has happened on the scope? Ay, 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 ay. So another effect here can be just overloading the radio. Let me put my camera back a bit so you can see just a little more of what it is I'm up to here. Let's interpret this. Sure. Okay, so I think the interpretation here is I've tuned beyond the range of the sweep. So now we're just starting to come into part of the sweep. And we're looking in the early part of the radio where the bandwidth is really, really wide. So all this is coming through. Why is it all schmozzled up like that and looking weird? Oh, I've hit the end of the road here. Can't tune any lower. Let me shrink the sweep width because I've got it way out there. Like way, way, way out there. Now, try and make sure the radio is tuned to it. There we go. So that's the tune. There, look at that. Now we're looking at a tuning curve. The problem here is when you see what you want, you might. I'm increasing the sweep, so I'm squeezing the display. Now that looks nice. That looks like something you would expect. It's both going up and going down because it's the whole RF signal. It has not been detected yet. We could do something with this, I think. Let me go back. Let me go. Gee, I wish I could get on that tube that I've got the clip lead on. I think I could probably do it if I'm just really careful. Again, kind of the same thing, only more of it. Actually, I don't even have to get on. I just have to get close. You can tell when I hit it, it fills the screen. So going back to the first one. What could I do here? We could lower the signal input. Oh, that looks perfect. Regardless, that's exactly what you would expect to see. Just go up and down. The top and bottom of this, like what is this kink here? I couldn't tell you. Interesting thing though. Let's go back to the very first tube again. Whoops. So again, first tube bandwidth is very, very wide. But I couldn't tell you why it looks like that. Wow, it looks like to be in the middle, you got to have the radio tuned to be 360 in the numbers. But I go to the next tube, and would it, just on the face of it, looks like it has to be tuned to 320. Like the two tunings are not aligned. If we go to the next one, I think I can put this. Whoops! I'll put this on. Oh, it is on times 10. So let me make my scope less sensitive here. Okay, we'll try to get on this thing. I think I'm there. Wow! It's just a big whopping square. Okay, tune the radio. What's that tell you? A big whopping square. What happened to the shape? Anybody explain this? What change did I make? Did I make some kind of change? Sweep width? We're not seeing anything. We're not seeing any effect here. The jumping around is I'm not making contact. Let's go to the next tube. Okay, next tube shows nothing. I increase the signal input. Okay, and then we'll tune the radio. Oh, there is something going by there. It's It's right in the middle right now, but it's very, very faint. Times 1. You can see a little more of it. More signal input. Just seems odd to me that the signal level seems to have dropped way off when I get to this tube. Again, just doing this test could be throwing everything off. I put this on times 1, didn't I? Let's put it back to times 10. We'll get rid of the capacitive curve that was developing the circle. Make it more sensitive here. Oh, heavens be. Bump the wire. Look at that. Hey. Yeah. That looks just beautiful. That looks like your absolutely classic response curve. And if I tune it, it should move left and right, which it does. That is a thing of beauty there. Wow. Okay, let's go to the next tube. And what kind of a debauchery is that? So we'll make the input signal lower. Ooh, some weird stuff has happened here. We've gone from a thing of beauty to some kind of weird thing here. It's going right off the top of the screen here. Let me reduce this. And I bump, there we are. It's RF because you can see how it's coloring in this part. Tune. Let's tune. The whole thing goes. So, you know, it's a response curve, and it's whacked out. Something terrible. Look at how sharp that thing is. Wait a minute. This has something to do with these phase settings. Oh, it really does. Oh, there's lots more fooling around we can do here. I'm fooling around with the phasing control. That was fun. And if I turn the RF gain down and up, okay, nothing surprising there. What other funny control have I got here to fool with? It's just the audio level, and I could. This is the B frequency oscillator, so no consequence. I've had the AVC on all this time. Turn it off. No consequence. So going back to the previous tube with the beautiful shape, the next tube, so tube numbers, so this is 1, 2, 3, so it's between 4. This is tube 4, everything looks great. Get to tube number 5 and things have gone wacko. And then we go to tube number, this is maybe the detector tube. Maybe that's why it looks funny. I'm not sure. And then we go to the next tube. This is an IF tube. Whoa! Hey, now that's a lovely display. Let's just shrink this guy a little bit here. Move too much. And just a touch more brightness. Tune the radio a bit. The beautiful shape is gone. It's now reflective of that weirdo shape coming from the tube just before it. Okay, we'll see the weirdo shape probably continues to the next tube. Oh, I say that didn't go so well. That did not go well. You could hear that in the headphones too, and I've got the volume turned minimum, so you shouldn't really hear anything but it. When I first put it on there, it looked to me like it bled off a voltage. Again, we got like a strong signal back here. Maybe I got these in the wrong order. I don't think so, because here's the audio tube, and I'm pretty sure this is the detector tube. We got to find out. We got to find out who's who here. So then, and then we get this. This weak, nothing. This weak, Nothing. Now voltage isn't everything. It's close to it though. You kind of expect these voltages to get bigger all the way along. Well, that was interesting. Let's find out what these tubes are doing. What are the tubes doing? So the tubes are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9. So starting with tube number 1. Okay, so 1 is the front end tube, and it's just taking the antenna signal, boosting it. It's then going through a transformer here. It looks like it's tuned transformer. And then it reaches the next tube, which would be tube number 2. Tube number 2, we saw a broad thing there too. When we get to tube number 3, this is the mixer tube right here, the one that I've got messed up. So once you pass this tube, then you're looking at IF stuff. How can that be? This is tube 5, tube 3. Hey, tube 4, what are you doing? Tube 4 down here? Yeah, tube 4. So this is an oscillator tube. Local oscillator tube. So you would expect to get quite a different view of things on this tube, I would think. It's just down here doing the local oscillator thing. So that's 4. Now, so if we go to 5, 5 is the first tube in the IF string. 5 at 1, 2, 3, 4, 5. So we've got oscillator, and what's tube 4? I'm wrong. I'm wrong. Jim, you're wrong. 1, 2, 3, 4. 1, 2, 3, 4. That's the detector tube. Oh, you idiot. I gotta stop and drink some coffee. Clearly that's what's happening. Not a detector tube, we're here. Converter tube. And then tube number 5 is the first IF. Where's the coil? I can see the coil, this big box here. Oh, right. Okay, so this is the crystal, filter, or crystal device, actual crystals in here. It's a plug-in, plug-out unit, and then down below there's a big iron box here, which is just the first IF coil. So we're coming transformer. We're coming out of 1, 2, 3. Coming out of 4. Coming out of 4. 4. I gotta wait some coffee. It's bad. It's bad. 1, 2, 3, 4, 5. So yeah, 5 comes after 4. Oh, am I ever turned around? 5. So here's the box. The big iron box. There's the crystal in it. So when you get here to tube number 5, you're starting at the IF. So it's IF, 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 3 of them. Three IF tubes. First, second, and they call it a detector here. This is tube number 7. 1, 2, 3, 4, 5, 6, 7. This is the one that makes all the noise when you move it. And then and then what? And then well, it's pretty curious what's going on between these first two tubes, but again, it could be when I do the test, I disturb the radio, and the result I get is a disturbed result, not a real McCoy. But it would look like the front end is tuned. First section's tuned one frequency, and the next section's tuned to another frequency. And that's not good. That would be very bad. And that's probably the coils in the box down here is probably responsible for this, if I'm interpreting it right. Yeah, I'm going to stop, have a little coffee now, and clear my head because I got too much going around in it. Okay, let's see if I can internalize some of this stuff now. So, considering what each tube is doing. So we have the first two tubes are just amplifying the antenna signal. and there's a bit of tuning. And probably these tuning capacitors right here are just lining right up with it. Then we have the next tube, which is tube number 3, is a mixer tube. And then we have tube number 4 in the lineup, which is actually the oscillator tube. So it's really one, This guy's doing something totally different. That's probably why we get a lovely response on this tube. This one, on the grid of that tube, number 3, on the grid of that tube, simply the signal coming from this transformer here. Where's that? I don't know where that is. So we have the crystal filter box there, and we have T2 and T3. Maybe T2, T3. There's one more. So I mean, I can certainly see the output of this one goes into the grid of this tube. So that's got to be this last one here. And then this one, it's got to be this one. This one, I don't know how it fits. Where does it fit in? It's this. This is T20. Have I not got another diagram that shows me this? Somewhere there must be a diagram. Basic stuff, not getting it straight. So going back again, two tubes doing RF only. Then that output of the RF stage fed to the mixer. Output of the mixer, which is going to show up on the grid, no, not this tube, of this tube. That's where I'm going wrong. It's really going from here to here. Let's look at those again. Let us look upon these things. Now what's happened? This guy's drifting here, so I'm going to set him back. And headphones, please. What do we hear? What do we hear? Perfect. That's what we should hear. Okay. We'll start again with these two tubes are RF tubes. Again, probably I'm disturbing the circuit when I do the test, even though I have my probe set to times 10. And we look, what do we see? We see basically nothing on that. No, we're not seeing really, just is the radio tuned properly? Yeah, we heard it. So this looks different than what I got last time, isn't it? Did I turn down the juice too much? Not appearing at all. That's on the times 10. Let's go times 1. Just get a big circle. Maybe when I turn this up full, the circle gets just a wee bit fuzzy. But wow. Next tube. Okay, so you see a little more fuzziness right in here. Moves around with the tuning. So at this point you can already see the response curve developing. I would say I'm on 1, 10, 1, 10. Let's leave it on 10. And I can't make my scope any more sensitive. And I can't really put more power to it. So that's what we get. Almost certainly, well, wait a minute. Let me listen to this. Yes, is that you, Kat? You want to go in the garage? Is that what it is? I have a cat that wants to go in the garage. There she is. You want to go in the garage? That's why she's standing right where she's standing. That's how they talk, you know. They communicate by position, angle, which direction they're facing in. Are they walking? Are they sitting? All these things. Okay, I have to go let her in the garage here. You guys just hang on for a sec. Come on. Come on. Okay, she likes being in the garage for some reason. Now, what was I up to? She rudely interrupted. The whole thing is falling apart. What was I gonna do? I was gonna look for that tuning difference that seemed so apparent before, and now I can't see it. Is it just because this guy's not making a connection again? Is this where I'm at? Don't think so. Listening to it. Just turn up just a little bit. Okay, well, yeah, that's right. What happens when nothing happens? Oh, bingo! There we are. So, again, I think this means the radio's not tuned. Tune it. Now that's pretty interesting, because it will look on the scope as if I've got it tuned properly, but we don't hear it anymore. Go to the next tube. So, again, this really does indicate these two are not tuned to a similar, at 12 megahertz anyway, they're not tuned similarly. Hey, how's this work at the other end of the band? I'm at 340 on a 0 to 500, so I'm in the middle. So we're going to go way down here. Oh, way up here. Wow, slam it at the end there, Jim. So 460, the capacitor's open, we're at the top. We're looking at 14 megahertz. Okay, so we're going to put the sweep up to 14 megahertz. Let me just change the SDR here. Okay, so 14 megahertz is right here. We'll change the frequency here. Hopefully we'll find it. There it comes. Oh, what's going on there? There's two of them. So this is probably an SDR effect, but you're seeing two of these guys. What you're hearing is coming from the old radio. Look at the beautiful patterns underneath on the waterfall display. Isn't that something? I'm an artist. Wow. Okay, enough artistry. So we'll put 14 roughly in the middle. You're just too close, man. Just too close. So, yeah, so we'll tune back into it. Now, the question was, what's it look like on these two tubes here? So let me see if I can get this in the middle. How do we know when it's in the middle? I think that's in the middle. Was that the thing? It wasn't tuned? Here we go. So again, similar, very broad band. If we tune this one in the middle now, not much you can do to it. Go to this one. Ooh. Too high a frequency, so I'm gonna reduce the sweep. Oh, look at that! I can wide. Oh my gosh! There we are. Sweep. I can make it wider. You know, to make it wider on the screen, Jim, you got to do this. Yeah, fill the screen there. That's right. So you see the peak. You tune it around. Stick the peak right on the center line. Go to the first tube, and the peak is way off. So it's doing something funny too. It's going back and forth. So often on these radios, when you get to the top end, the capacitor is opening all the way or closing all the way. The capacitance actually goes a little wonky. Just because of the shape of the plates, and funny stuff happens right at the end. That's probably what's going on. So we can't even tune, really, the front. We can't even get the peak into the middle. So it really does look like. Now, what happens if I shake this coil box around? Again, just because I'm a scaredy cat. Put on this fantastic rubber glove. It's got an extra finger in it. Okay, now we're going to shake this around and watch what happens. We'll watch on this one, this tube, because it's nicer. Okay, we're going to shake this around. Oh, that pretty much cleared it, didn't it? How come we don't hear it anymore, but we still see it? I'm manipulating the manipulating this. It may generate a loud pop at some point too. So that's not doing too much, is it? Maybe because I've worked this a few times now, the contacts have kind of self-cleaned themselves and they're not acting funny. Go back to the first tube and wiggle this thing. Very important to know this when it comes time to do the alignment. Seems okay. I mean, it must be the case that you can push these things in and out and the radio works fine because it was built this way and people use them forever. So it must actually be quite reliable, as wonky as it looks. I've only got 4 fingers. What has happened? So there are adjustments to adjust the tuning here. I'm nowhere near ready to do that. Now I do know now what happens is the next tube in the line, tube number 3, is getting the output from T20, and it's called the mixer tube. So I should be able to see this same kind of signal I'm looking at now getting onto the grid of this mixer tube. Can you see it faintly there? There's this box thing. I don't know what that is. Okay. The next tube is the oscillator tube. And so we would expect to see, what do you expect to see with this kind of test? So we shouldn't really see anything. Like the sweep, doesn't the sweep become meaningless looking at an oscillator tube? Okay, but we go to the next tube and we're seeing the signal again. Now after getting mixed. What a beauty that is. Tune it around a little bit. Oh, right at the end of the run. Let me come back. There we are. Look at all the interesting stuff. So it seems to me that when you pass signals through a mixer, you get the product you're after, 455 kilohertz, and everything else under the sun can come out of this thing. All kinds of signals can get mixed in there. Let me fiddle with the sweep width. That's more and more width. Wow, there's something going really crazy there. What is that? That must be, I don't know, coming out of my device here. Why would it adopt that shape? Questions, so many questions. Okay, and we're making the more and broader sweep width on it. So more and more signals going into the front end. And all kinds of crap coming out of the mixer. But now we'll go to the first IF tube here. And now, what do I want? Sweep width. Let's shrink down the sweep width to something like that. Wow, okay, how do you interpret this now? It's going way up here, way up, way off. Let me turn this sensitivity. I bumped the wire again. See a little bump and then this could be mistuned IF. Could be one transformer, one coil is tuned way over here. It needs to be in with the rest. And this frequency, shouldn't it be fixed now? It's not fixed at all. I'm tuning the radio and it's going all over the place. Isn't that supposed to be fixed at that point? 455? Well, we're not looking anywhere near 4. What are we doing here? What are we doing? So I'm probably seeing remnants of the RF signal. It's probably what this is. Remnants of the RF signal. And so there's another signal, an IF signal, which we would really be better looking for on the SDR. The SDR is a low impedance input, so I don't really want to touch it to the grid here, plus I'll blow the front of the SDR off. Even 10 volts might be enough to blow it up, so I don't want to do that. But I could hold it close with a coil and see if we can pick up some nonsense from the tube. We probably can. Okay, so let's do that. So we'll look with the SDR. We'll look with the SDR. Okay. I need another one of these, and I need a coiled up. Where is it? I saw it here somewhere. Here it is. Coiled up clip lead. So this will be my pickup coil. It's a little big for the job, Jim. Let me use a more suitable one here. We'll try this. Okay, so this is nothing more than a coil. There's a coil in here and a connector. I'm just going to hook up like this. Try anyway. There we are. And then I can go boom, boom, and see what we can see. Now I'm going to replace the SDR input here. So the SDR is this guy here. So I won't be able to monitor the sweep going into the radio anymore. There we are. Oh, drop it like that. Too many wires. Too many wires. My mother complained about that all the time. There's too many wires, Jim. Okay, on the SDR. So we're tuned. We want to go down to way down here to 4, about 455. Just about. So that's where 455 is. You know, if you can see it, but here's the bottom of the AM band right here, and just below it is the 455. There's a signal right here. I don't know what that is. And if I manipulate the antenna coil here a bit, you can see there's a response. Not much, but there's something. Oh, let's put this a little differently here. Okay, still got the response. Yeah. Okay, here we go. We're going to start with right down here. So, did you see something pop up? Take it out, put it in. Right there. Well, I can make this sit in here, can I? Can I get it to sit there? Sit there. Oh, perfect. Now, what we're going to do is we're going to zoom in on this part of the screen. In fact, I'm going to, yeah, we'll just zoom in on this. Zoom in. So this is the IF area here, and we can hear this. It's the same buzz. Okay, I've tuned the radio a bit. Let's listen. We're listening to the old radio now. Not very dramatic. We are at the start of the IF where the signal is weak. Oh, what's that? Okay, you gotta be able to see my hand here, what I'm doing to the radio. I'm doing this. So if you look down at the SDR, you'll see that we're sitting right on 455 here, and any signal that's in this area, in this area, we can potentially hear come out of the speaker because it's in the pass band of the IF. Doesn't seem very strong to me. Just shrunk the sweep length. Now we can't see what's going on with the sweep because I don't have the SDR connected there. It'd be more fun to be tuning actual stations doing this. So not sure why there's something on there all the time. We must be way out of the sweep range by now. So I'm going to adjust the sweep range. I'm going to adjust, yeah, the you can see it go by there. Okay, should be sweeping. Come on, internet. What's happening, man? Terrible things have happened. Oh, because I got this thing expanded. Something. I got this SDR expanded a lot. Well, this is saying there isn't much in the SDR in the IF. Is it because I don't have it tuned? Where'd it go? Where'd it go, man? Is it the wire? Did I bump the wire? Oh my gosh! Don't do this to me. We've lost it. Captain, I can't pick the signal up anymore. We don't know where we're going. We don't know what we're doing. Oh, everything fell apart when I went to do this. Well, let's move this. Let's move the pickup from the weakest part to the strongest part. So this is the middle. This one, potentially the strongest. Let's try this guy. Should be a stronger IF signal there. There we are. Oh, where did that guy show up there? Did that 480 just show up there? No. I don't know what the 480 is. Can be nonsense with the SDR. These SDRs, they have a lot, the cheap ones, they have a lot of nonsense in them. A lot of nonsense. Something like what I'm doing here is kind of nonsensical. I'm going to get rid of the zoom because it's throwing me off. Okay, we can see edge of the. Looks like this might be the edge of the sweep. Let's change the sweep. Yes. I think I had the sweep frequency way low. I don't remember. So the sweep is at RF frequency. There comes the other end finally. Even though we're looking at it in the IF. I'm trying to reduce the sweep way down. How is this seeing the sweep like that? Supposedly I'm only seeing the wow. Totally lost my mind here. So we're looking at, on the SDR, we're seeing the sweep between 600 and 900 kilohertz. But I think I'm picking it up in the IF. It shouldn't be there. So maybe there's just a screaming signal in here and my coil's picking it up no matter where I put it. Like this test didn't work at all. The the sweep signal. What did I do here? I did something stupid. That is usually the case, by the way. No. This coil is hooked up to the SDR. Why see the sweep so I'm a mile away here? What if I pull that off? You can still see it. Well, I don't know why that is. I really don't, because this thing is sweeping way up at 10 or 12 megahertz. And I'm looking at a sweep signal, a little tiny one at 700 kilo. I don't understand. Okay, so this is not working, which is often what happens when I try these things. I try these things out, and they don't work. The worst case would be it's misleading, and I'd rather say, oh, this didn't work, and walk away from it than try to interpret it, if that's the case. I really don't get this. So we should see a very strong, like what this is suggesting is the IF signal of the sweep is way up at 600 kilohertz. Not where it should be, down at 455. Now, is it just that I'm ramming a whopper of a signal here into the radio? So I'm turning down the signal level, but it's not really going away. I'll change the input frequency. This will make it shift. We got to listen to this. What can we hear? We are listening to it. We're not hearing anything. We're listening to it and not hearing anything. Oh boy, am I way off. Way off here. Something's gone way off. See, there's a signal in the IF. We should hear. We should hear it. We don't hear it. So, where do I think I have this tuned? I have this tuned to around 200, around 9, at a megahertz. It's around 10 and a half. Let's go there with the SDR and see if we can see a 10 and a half signal. Now, where would I see this? I would have to hook this back up. Not there, that's for sure. Maybe here. Oh, that's interesting. Put that there and you can hear a hiss. Well, that's also interesting. The signal at 10.7, whatever it is coming out of this radio. Ooh. Whoa. What's down here? So I'm right near the capacitor here. Oh, what's way down in this area? Oh my gosh, what is going on? Okay, so is that the local oscillator? 10.750. If that's a local oscillator, then moving this, yeah, that's what that is. That's the local oscillator. Well, that'll give me an idea what the radio is really tuned to. So I put the local oscillator at 11,455, let's say. 11,455. Somewhere around here. So around 11 megahertz now is where it should be tuned. So can we see can we see this signal here? Sure can. Well, why did it stop suddenly? We're doing. Holy smokes! I got too many loose wires in here. That's what we're really hearing. Wow, okay. Turn that baby down. And grab the sensor again. I just threw it somewhere. Here it is. Oscillator frequency 11 point something, and hard to see, but right around 11 megahertz on the SDR is the, there it is, now you can see it better. Okay, we're in a good spot now. Good spot for what? I don't know. We're in a good spot. We're in a good spot. Well, okay, stuff just going around in my head. Vroom, 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 like this now. Too much stuff going on here. Once again, too many angles all at once. Too many, excuse me, loose wires and stuff like that. What have we found out so far? I found out, once again, I confuse easy. We found that out. It sure looks like the tuning of these first two stages is very bad. Tried doing it at, I was kind of in the middle. I tried going to one end and seeing if it's bad there too, and it didn't work out. I lost control of everything. So as far as we know, it's off everywhere. The two, so let's see, so we have some kind of arrangement right off the antenna. Go through the tube, then we have another coil here, and then we go through the tube and have another one here. So I have 3 tuned RF circuits. Wow, 3 of them. And are these in the can? No, these are, yeah, these would be in the can. Selectivity control is all this stuff up here, and then from then on it's not in the can, it's in these cans, not this can down here. So if I wanted to try to affect that, I would have to tune down in the down inside this thing. Now the way you do that, you have a very long screwdriver, goes right down the front here, and you can get it into holes, tuning holes that are in the top. Tune it. Sure seems like it needs that. Beyond that, I don't think I figured anything out that's reliable. It looked like a lot of nonsense going on down here. Nonsense signals, not a nice curve. It's all jumbled up, nonsensical stuff. Yeah. Okay, you know what? I think that's enough. That's enough for me today to think about and see if I can't kind of improve this approach a little bit, and we'll look tomorrow at actually tuning this front end. So again, I'm on the learning curve here. It's very painful. I've never worked on this particular type of radio or model of radio at all, and yeah, School of Hard Knocks. I like the School of Hard Knocks myself. Okay, that's it. Thanks a lot for watching. We'll see if we can do something a little more purposeful tomorrow.